Okay, so it's time to start with our webinar. First of all, welcome to everybody, and thank you for being here with us today. Maybe some of you already know me, but many others certainly not. So let me introduce myself. My name is Pietro Grottoli. I'm the sales manager here in LAUMAS. And today I'm going to be the presenter of this event. So, what are we talking about today? Today we are going to introduce you the new firmware version that we are releasing for our multi-channel weight transmitters, series TLB4, CLM8 and TLM8. In the last years, many of you asked to be able to manage completely the parameters of our weight transmitters from the PLC via fieldbus. And so this is what we have done, and this is what we will show you today. But we have also added to this new firmware version a new software especially made for filling systems, a new setting to fulfill the CC-Link regulations, and some other useful features. To explain you all of this news, I will give now the floor to my colleague, Mr. Matteo Grisanti, who is going to be the speaker of this meeting. Thank you.
Thank you, Pietro. Hello, everybody. Thank you for attending this webinar. We can now start the first section where, with the support of a short PowerPoint presentation, we will see the main characteristics of all the new features available with the last firmware version for our multi-channel weight transmitters. In this slide, all these new features are summarized, but before going on with the details for each one of them, a brief note. All the executable files needed to update a multi-channel transmitter already in your possession are now available to be downloaded and used for upgrade procedures with the support of our service software Instrument Manager. If you don't have available Instrument Manager yet, it's not a problem. You can download it for free directly from our website pages. So now we can start with the first new features that we consider the most important offered by this firmware version, specifically the complete control via fieldbuses of the instrument. Independently by the communication interface you will use in your applications or products, exploiting this function, you will be able to obtain a complete control of the instrument by remote. What does it mean? First, you will be able to obtain the full access to all the parameters composing the instrument configuration. This means to be able to access and modify the parameters regarding the theoretical calibration or the parameters regarding the setup of the digital filter applied by the instrument on the calculated weight values. Again, you will be able to access to the parameters needed to set up the zeroing functions or the digital inputs and outputs functioning, as you will be able to properly set up by remote all the advanced diagnostic functionalities offered by the multi-channel weight transmitters due to their multi-channel architecture. Again, during your weighing system's functioning, the complete control will allow you to not only retrieve the calculated weight, but you will be able also to get more detailed information about alarms or faults detected by the instrument itself, also depending by its configuration. And finally, the complete control feature will allow you to implement in your application a full access to all the procedures needed for the installation and the setup of your weighing systems. This means to be able to execute by remote not only a real calibration with sample weight procedure or zeros or tears, but also, for example, you will be able to access and execute by remote a digital equalization. A last observation about this feature: the development of this function has been realized without any modification to both the structure of the data exchanged by the instruments on the different communication interfaces and the descriptive files associated to the different fieldbus interfaces, except for the CC-link interface, for a reason we will see shortly in this presentation. This, in our opinion, is a very important aspect that we would like to share with you, because this for you means to be able at the same time to use instruments programmed with this firmware version to substitute other multi-channel transmitters in your applications, maybe because damaged, without the need to modify your PLCs or PC software. And obviously, you will be able to plan new developments with new functionalities or improving the current functionalities of your applications. Well, now we can change the topic of our discussion. Now we will speak about diagnostic. In fact, in this firmware version, a new diagnostic functionality is available. More in detail, it will be available a channels overload control function. Enabling this function on a multi-channel transmitter, associating it to one of the available digital outputs, and after setting a proper weight threshold, the instrument will start to continuously monitor the load distribution on the scale among all the active input channels. And if at least one of the monitored load components results to be above the previously set weight threshold, a specific alarm condition will be signaled by the instrument, closing the associated digital outputs. Where could this function be useful? In our opinion, it could be very helpful in lifting applications, for example, in order to allow you to implement monitoring functionalities able to detect a not correctly loaded platform. So a platform working in conditions that could cause damages to, for example, the mechanical structure or a not correct functioning for the whole application. Now we change the topic again. Now we will speak about available programs. With this firmware version, in fact, a new program is available on all our multi-channel transmitters. Namely, it is available a batching program that you could exploit to realize single product load batching applications. Which are the main characteristics of this program? First, you will have available one batching formula composed by two weight thresholds. This means to be able to implement applications executing two speeds batchings. The formula can be programmed by both the instrument manual and by remote. Again, exploiting this program, you will be able to interface the multi-channel weight transmitter to some of the components of your application, demanding to it its management using the set of digital inputs and outputs available on the transmitter itself. Then, a set of specific functionalities are available to optimize the performances of your batching application in terms of both batching speed and batching accuracy. We are referring to the fall function, automatic or manual, the tapping function, and the slow function. With this batching program, also a tolerance function is available. Using this function, you will be able to implement a specific control executed directly by the instrument on the batched quantities. After defining a specific weight limit, it will be used by the instrument at the end of each executed batching cycle to control the batched quantity, and if one of the batched quantity results to be outside this limit, a specific alarm condition will be signaled by the instrument. And finally, the batching program available makes possible to demand to the instrument the consumptions management. The instrument enabling this function will be able to automatically manage and update the product quantity used by the batching application, updating it at the end of each executed cycle with the real batched quantity of the product. A last note about this program, as for all the other parameters or functionalities, also in case of this program, all the parameters needed to configure the instrument functioning will be fully accessible by remote for writing or reading operations, and during your system functioning you will be able to completely manage the instrument by remote all the time. And a last topic regarding specifically our CC-Link models. As I told in the first slide of this presentation, CC-Link interface has been changed in this last firmware version in terms of both the structure of the data exchanged by the instrument on the fieldbus and in terms of the associated descriptive files. The reason is that in the last months, LAUMAS faced with the TLB4 and TLM8 CC-Link instruments the certification procedure executed by the CLPA consortium. The procedure has been successfully completed in the last October, and to have available a certified interface means that these instruments has been verified to be fully compliant with a set of technical standards created, defined and maintained directly by the CLPA. The compliance to these standards means that these instruments can be installed in any CC-Link network without the risk to create issues about the network correct functioning or compatibility issues with other CC-Link devices contemporarily installed in the same network. A last note about this certification activity: the structure of the data exchanged by the instrument on the fieldbus has been developed to be fully compliant with the weight indicator profile, whose specifications are always maintained again by the CLPA consortium. To be compliant with a specific profile means that the distribution, the position of the different values exchanged on the fieldbus follow specific rules, and this aspect could be useful for software developer, making it easier for them to get the right data among all those exchanged by the instrument on the fieldbus itself. Well, this is the last slide of our short introduction. Now we can switch to our demonstration, where we will see together some of this new functionality directly at work on a real weighing system. So give me only a few seconds to switch off the PowerPoint presentation. Now, on your screens, you should be able to see on the left low corner an image, a webcam image of the scale we will use. We can zoom on it a moment. As you should be able to see, this scale is composed by 4 30 kilograms load cells connected to one TL-made Profinet IO multi-channel weight transmitters, already communicating with a S7 1200 Siemens PLC. Then, always on your screen, you should be able to see on the left the TIA portal interface, showing to you a table of variables we will use for our demonstration. And on the right, our TL-made communication protocols that we think to be the main technical reference in terms of documentation you should strictly follow when you plan to implement functionalities regarding the remote control of our multi-channel transmitters, and in order to correctly exploit all the new features we are showing to you today. So before starting to work on our real system, a few words about how to manage this document. First, in the introduction, a specific table is present and it gives us a very important information because depending by the communication interface we are going to use in our system, it gives us the reference we should follow on all the other paragraphs of the document to find the right instructions needed to correctly execute all the procedures allowed by the remote control functionality. For example, in this case, we will use the Profinet IO interface, and this table says to us to follow the generic interface references about in all the paragraphs of the document. Then we can take a short look to the paragraph specific for the Profinet IO interface. In this paragraph, you will find all the information needed to correctly set up the communication between the instrument and your PLC. And among this information, very useful, a couple of tables describing the structure of the data exchanged by the instrument on the field bus for both output and input directions. For example, these information are very useful to define a set of variables as the variables declared here in our TIA portal interface, exploiting the information on the table. For example, in our interface, we declare the variables to get the gross and net weight values by the instrument. We declared variables to work with the exchange registers available on the exchange data, both exchange register, input and output. Then we declare the variable specific for the command register field. Command register is a very important field among the input data to the instrument because writing specific numeric command codes into this field, you will be able to request the execution of specific operations to the instrument, by the instrument. And then we declared a series of Boolean variables able to give us a clear description of the working status of our instrument. These Boolean variables have been declared taking into account the content of the status register field. And always in our documentation, a specific table is available giving to us a detailed description of how this status register is composed, explaining the meaning of each one of its bits. In this case, we used some of the available signaling offered by the status register, as the weight stability condition or the weight near to zero condition, or again, we get the information about the negative sign of the received weight values, and some of the signaling regarding error conditions that can be detected by the instrument during its working. A brief note about the weight values before going on. Both the gross and net weight are transmitted on the field bus by the instrument as absolute values. The corresponding sign is included in the specific bits of the status register, and without taking care of the decimal values. Okay. Now, the scale currently is not working, giving to us a correct weight value, because now it is at its default configuration. So we can start our demonstration, going to execute the theoretical calibration. We can find the right paragraph in the manual, okay? And in the paragraph, we see that the first parameter we have to set is the theoretical full scale, a parameter corresponding to the sum of the capacities of the installed load cells. In this case, the full capacity of our system is 120 kilograms. To set this parameter by remote, we have to search for the generic interface reference and follow the related procedure. Now we are going to write the values, so the procedure is described here. So we have to write in the out exchange register the requested value. In the command register, we have to write the corresponding command code. And we have to send all this information to the instrument. Very well. Now we can observe two different things. Also taking a look to the instrument, we see that the display weight is changed because the instrument has correctly applied the value we have sent to it. But the correct execution of this operation is also shown by the data get by the instrument. In fact, in the input exchange register, anytime you execute a writing operation or a procedures, you will be able to monitor the execution status of the requested command. And if in the exchange register iWord you see the same command code previously sent to the instrument, it means that the operation has been correctly executed by the instrument. Another note, as you can see, the scale is calculating a 5.48 value, but the received weight value is 548, as I told you, because in our convention we remove the decimal point from the transmitted weight. We can now proceed with the other steps of the theoretical calibration. We can actually skip the sensitivity setting because the default value for this parameter, 2 millivolt per volt, correspond to the expected value for the installed loaded cells. And we can focus now on the division. The instrument, after receiving the new full-scale value, has already set a different value for the division. Specifically, now it's working with a 0.02 division value. That can be also seen by the instrument display. For example, now we can decide to set as division for our system 0.01. Using the manual, we see in this table that the index corresponding to the requested value is 12. Now we can go to the procedures, search for generic reference, and apply what described in the writing section. Again, we have to write the requested value in the exchange register field and write the right command code in the command register, and sending the data to the instrument, we receive the correct execution feedback by the instrument, and in fact we can notice that the division applied now by the instrument is 0.01 as requested. We can exploit this parameter to take a look to another aspect of the execution status feedback mechanism. If we try to set a wrong value for this parameter, the division, now 20 is not one of the admitted values. The admitted values in this case are from 0 to 18, and we send this value to the instrument. We see that in the exchange register a -2 code has been received. In a specific paragraph of our manual, we have available a table explaining to us the meaning of this value. As you can see from the table also, -2 correspond to the message, the limits allowed for the parameter have been exceeded, and obviously not applied by the instrument. Well, with the division, we can consider concluded the theoretical calibration, so we can proceed zeroing our scale using the command code 100. We see the correctly executed operation feedback and the weight value equal to 0, and also the corresponding flag is true now. Now, using a sample weight, we can make a test. Placing the weight on the scale, we can check for the calculated weight, if it's correct or not. And we can also try to move the weight on different points on our platform. And we can observe a couple of things. First, the calculated weight is not corrected, probably because slight differences in the sensitivity values, in the real sensitivity values of the installed load cells. And also, we see that the calculated weight is not uniform along all the platform surface. So, we can, first of all, correct the last issue, executing our digital equalization procedure. We can go to the corresponding paragraph of the manual, search for the right reference, and keep an eye on the procedure described. So, We start the procedure with the right command code sent to the instrument, and if correctly received, we can go on. The further step, the next step is this one, acquisition of the equalization 0. To execute it, we have to send another command code with in the exchange register the 0 value. And if correctly executed, we can start a cycle composed by a number of steps equal to the load cells installed on our system. In this case, we have to execute 4 steps, and for each step we have to place the weight that we will use, placing it on one of the load cells, and follow our instructions that say to us to write the index of our cycle step in the exchange register and the 6701 command code in the command register. And we send the data to the instrument. The feedback says to us that the step has been correctly executed, so we can proceed. We should now move the weight on another load cell and send to the instrument the same command, but with an increased value for the index. But now I send the data, but without moving the weight on a different load cell, and we receive an error signaling in the exchange register as feedback for the command execution. We can see in the corresponding table what the signaling received means. Here, the table. The -3 value in the high word corresponds to an execution error, and the 9 code in the low word correspond to the current load cell has already been equalized. So we are able to correct our procedure, and we can try to repeat the step, this time placing the weight in the right place. So we can move the weight, then we have to wait for the weight stability, and we can proceed with the equalization step. Okay, this time it has been correctly executed, and we can go on with the other steps. This is the third step, so the index is 3. Okay, and the fourth step. Okay. When the cycle is completed, we can execute the last step of the procedure, this one, sending the 6702 command code to the instrument. Okay. Now we can zero the scale again, because the coefficients calculated by the equalization can cause a little changing in the calculated weight. And we can now test our scale functioning, placing the same weight on a different point of our platform, and we can easily verify that now the calculated weight is uniform on all the scale surface. We can complete our calibration with a real calibration, because we have again one issue the weight calculated by the instrument is not correct again. We can always follow what's described in this manual. And for the generic interface, the sequence is this one. Okay, here we are with the procedure. We have already placed the weight on the scale, so we have to write in the exchange register the correct value, always taking into account the number of decimal. So we don't write 5, but we have to write 500 in order to obtain 5.00 kilograms applied, and then we can follow the sequence of command codes needed to be sent to the instrument. First, second command code here. Very well. And now we can send the last command code. And as described in the manual, we have to check the value in the exchange register. If the value is 0, it means that the calibration point has been correctly added to this instrument calibration curve. Now the scale is correctly calibrated, and we can, for example, try one of the other new features available in this firmware version. Namely, we can test the channel overload monitoring function. First, we have to enable the function. To do it, we have to go to the paragraph specific for input and output setting, where we find a specific table needed to calculate the value that we have to send to the instrument to obtain the right output configuration. Among all the settings that it is possible to apply, in this case, we have to specifically focus on the function. We have to set the channel overload function, and we can consider to work with a normally open digital output. Then we can execute the procedure to correctly set one of our digital output, let's say the digital output number 1. To do it, we have to write in the high word of the exchange register the index of the digital output we want to configure. Then we have to write in the low word the numeric value obtained analyzing this table, and depending by the configuration we want for this output. And we have to send to the command register the right command code. Okay. If the configuration is correctly executed by the instrument, as in this case, we can go on and we have to set our weight threshold. Also in this case, we can rely on the procedure described in the manual. Specifically, we have to refer to the generic interface. Now, to define the threshold weight, the weight threshold, we have to write the requested value in the command register, always take into account the decimals. So if we want to set 7.5 kilograms threshold, we have to write 750 due to our current calibration. And we have to write the right command code, as always, in the command register. Well, the threshold has been correctly set, and we can now test this function at work. So if we put on a load cell of our scale a 5 kilogram weight, we see that nothing happened. Especially we can take a look to this Boolean flag corresponding to the current state of our digital output number 1. But if we put another 5 kilograms weight on the same load cell, we see the calculated weight is equal to 10 kilograms. And in this case, we see that the digital output switched, the instrument closed the digital output because on a single load cell, we applied a total weight component above the threshold we previously set. Obviously, the monitoring of the instrument is continuous. This means that as soon as we remove the overload condition, it will be correctly signaled by the instrument, opening the corresponding digital output. Now, we would like to conclude our demonstration with a couple of further tests regarding new functionalities, new features offered by the remote control. The first one is the possibility to get the load percentages on the field bus by the instrument. Again, we can go to the right paragraph, and where we see that in case of the generic interface, a set of 4 specific command codes are available, each one needed to obtain by the instrument the percentages related to a couple of the input channels. We implemented this mechanism in this way to offer to you the possibility to get at the same time the total weight value, gross and net, and the load percentages, because this configuration, in our opinion, could be helpful for your application. And if more than 2 channels are used in your weighing system, you can think to implement in your software, for example, a polling cycle, continuously switching the command code sent to the instrument in order to collect with a constant frequency all the load percentages. So, in our system, we connected the 4 load cells to channels 1, 2, 5, and 6. So if we want to get the percentages regarding channels 1 and 2, we have to write in the command register field the 6804 command code, send it to the instrument, and we have to read the content of the exchange register here. In the I word, we find the percentage regarding the channel 1, expressed with a 0.1% accuracy, but without the decimal point displayed. This means in this case we have a load percentage equal to 13.7% associated to the channel 1, and a 37.2% value for the channel 2 percentage, load percentage. In the same way, sending the 6806 command code to the instrument, we will be able to get the load percentages corresponding respectively to the channel 5 in the I word, 35.1, and to the channel 6, 13.8. Always being able to get at the same time the weight value. Okay? A very last test about the diagnostic. We can now simulate the fault condition on our scale. We removed one connection, obtaining an RCL1 signaling on the instrument display. And we see the load cell error flag to true. If we want to obtain more information about this fault condition, now we are able to do it always by remote, with a specific alarm management feature we implemented. sending the right command code to the instrument using the command register field. We obtain a specific code in the exchange register. We can interpret with the help of our manual, and we see that the command code 1 in the I word, corresponding here to the ERC code, corresponds to a load cell error, and the command code 2 in the low word corresponds to a NER cell 1 error condition in the AERC register. Obviously, we hope this feature will make for you possible to implement more detailed diagnostic functionalities on your application, allowing, for example, your final user to get correct signaling on a specific error condition without the need to access to electric cabinet where our instruments will be installed. Okay, this is the last test for our demonstration. So it is concluded, and I can now give the floor to my colleague Pietro, that will lead in the final section of the webinar, the question and answer time. So please, Pietro.
Okay. So, thank you very much, Matteo. I think this introduction was really useful because we have seen a lot of new features and functionalities that initially were available just on the transmitter, and that now you can remote completely to your PLC, so it can simplify your life and make your system more advanced, let's say. We can now start checking at your questions. We have the first one that came almost in the beginning of the presentation, Matteo.
Okay.
And the question is from Mr. Javier, who's asking, to make the remote adjustment, we need a software or just the IP address? I think he's talking about the remote adjustment. I think he means the remote setting and calibration.
Okay, obviously it depends from the communication interface the user wants to use. In case of, for example, Profinet.io, the IP address is usually automatically assigned by the PLC, at least in case of Siemens PLCs, once the network is put at work by the PLC itself, for example. So to assign the IP address to the instrument, you should work on the PLC project in a specific view, obviously, of the development software. For other communication interface, we have the IP address among the values accessible by menu. So in that case, you should set the IP address before starting the communication with the instrument.
Okay, thank you very much, Matteo. If the fieldbus is TCP/IP, can we use Instrument Manager over TCP/IP instead of RS485? My case is TLB4.
Yes, it's clear. No, actually no. With the current version available of Instrument Manager, you are able to interface to the instrument with a serial connection only. Obviously, we are working on new developments for Instrument Manager, and we already take into account the TCP/IP connection as a way to connect to the instruments, but we are reasoning to offer this opportunity, let's say, maybe on new instruments and not on the current models available for you.
Okay. Another question from Hanno. Hello, is there a direct way to read the weight on each channel, or does it have to be calculated from the total and the respective percentages?
No, there is no way to obtain a weight per channel. This is because these instruments have been designed to, in a way, to not offer this kind of functionality. Obviously, you can rely on the total weight and the percentages, obviously. Or you can work with the raw points. In fact, always in this firmware version is available the possibility to switch to a different configuration of the exchange data in order to get the raw ADC points for each channel, but in that case, the values obtained are not filtered, neither calibrated. So you should work directly on your software to make them useful for your application and to transform them in weight values. Obviously, also this kind of functionality that of let's say a multi-scale configuration is one of the features we think to make available in the next generation of our transmitters. We are working on it, but we need more time to conclude our work.
Okay, thank you, Matteo. One more question. So Hanno was happy about your answer. It was very clear. So we have a question from Mr. Mateus that says, you have mentioned that those changing came with the new firmware. Already installed transmitters can be updated to get those upgrades?
Obviously, yes. As I told you, as I told in the beginning of the presentation, you also have already available the executable files needed for this upgrade to be downloaded and used for the upgrade with the help of our instrument manager, for sure. And all the functionalities will be available also on instruments already at your disposition and now programmed with an older firmware version.
Okay, good. Some more questions are coming, so the discussion is getting more and more interesting.
Very well.
So we have a question from Ralph, who's asking, will the new functions be implemented to other transmitters, indicators in the future?
I think no for the actual products, because we planned to focus more resources on the development of new instruments. So we think that at the moment this kind of functionalities will be available on the multi-channel weight transmitters only.
Okay, good, Matteo. We have also a question from Remco, who's asking, I assume for the percentages to work, you need a system with multiple identical load cells.
Multiple identical?
Yeah, I think he means more load cells with same capacity and same sensitivity.
Yeah, actually you could exploit the digital equalization to make, let's say, the load cells equals for the instrument, because obviously with this procedure you would be able to delete the differences in capacities or sensitivities, obviously. But obviously it depends from the reason you are using a system with different load cells installed on it. Maybe you want to use different load cells because you need them, or better, you need to obtain different values for the different load cells. It depends from your application.
Yeah, I would add that usually when you realize a scale or a weighing system composed of more than one load cell, the load cells have to be with the same capacity and same sensitivity. Then you can play with it with such transmitters and install load cells with different capacities and sensitivities, but that's not so correct, let's say. Okay, so let's move to the next question. Michael is asking, can we find the firmware release notes somewhere?
We are working on it. Obviously, we have a logs for all the released firmware versions, but now he's for internal use only, for example, for technical assistance activities. but we are working on it to produce documents to share with you with all the releases available for our instruments.
Okay, good. Then I can answer to this question that comes again from Ralph. Are the manuals, etc., on the website up to date? Yes, they have been up to date, updated a couple of days ago, so we waited for this event to update all the documentation on our website. And so the answer is yes. If you check out the manual or if you download it from the website, you will find the correct one with all these news. We have now a question from Ruinel. I hope I spelled the name in the right way. That is asking, can you show something from the dosing capacity? How does the program works? What are the parameters?
No, actually it's not so simple, because now we don't have any kind of product that can be used to dose a recipient or a container for it. Maybe we will work to produce a specific maybe video tutorial to explain just a little how to set the program and how to work with the parameters regarding it in order to correctly configure the instrument.
We have a question from Mateus that's asking, I wonder if multiple channel transmitters could be used to monitor two different scales, one load cell each at the same time.
Yes, but only in our current firmware version and instrument architecture, exploiting the raw point functionality. So you are able to manage a similar weighing system, but from the instrument you will be able to get the ADC raw points only, and you should develop a specific software able to filter the obtained values and to use them to calibrate your system and obtain a real weight value for each scale connected to the instrument.
It seems we have no more questions. So basically that's all from our side. I remind you, if you have any question or doubt, just send an email to sales@laumas.it, and our sales department, with the support of our R&D, will try to answer you as soon as possible. So that's it. Thank you again. Keep well, and I hope to see all of you very soon. Thank you very much.
Thank you. Bye.